We feel that this technology has quite a bit of potential for a number of different applications, and we'd like to see it brought out into the marketplace as soon as we can. So we've established a company called Verdox. Verdox is really a takeoff on the term redox, because we are working with redox potentials, but rather than have a red ox, we have a green ox. That's Verdox is the name. So we've established the company. It's been incorporated a few months ago. We actually have this first round of seed funding has been completed, and we are moving into our facilities very shortly and working with a number of possible customers in terms of how we can go about installing it and de-risking it on small-scale type operations, and then work into larger scale devices and the like. I should point out that what we've talked about here is CO2 capture, but there are lots of other issues as well. SO2, sulfur dioxide, is a big one, particularly with the International Maritime Organization when they're putting restrictions on how SO2 can be disposed of on ships around the world. And there are very strong regulations now coming in that you need to sort of prevent the disposal of SO2 in the conventional ways. And people are looking at putting in expensive scrubbers, chemical scrubbers, so you need to have lots of chemicals on board and so on. In our system, we can tailor it so that it can capture the SO2 and leave the CO2, because for these particular applications, we're not interested in removing the CO2 from the exhaust stream. We need to remove the SO2. So we can tailor our system to be very much SO2 friendly, you might say. Everything I've discussed so far has been related to low temperature ambient type environments where we don't want to actually heat up anything. But there are many, many processes where the gases coming off for CO2 capture are actually at very high temperatures. Coal-fired power plants is one of them. Any of these power plants, you've got CO2 coming off at very high temperatures. The other processes and the steel and cement industries where the off gas is at very high temperatures. There's hydrogen production by steam methane reforming. There's all sorts of other types of chemical processes where CO2 is emitted at a very high temperature. And so what you normally do is cool this down to more reasonable ambient temperatures and then do the capture. But this leads to degradation of the heat value of what we have and a lot of wasted heat and heat integration issues. So what we're looking at, are there ways in which we can capture CO2 at those high temperatures at which it's actually performed, it's actually produced. And we can do that by using some new solvents that we found. In fact, what we were looking at initially was solid absorbents that could capture CO2 at the high temperatures and then release them again at slightly higher temperatures, which is a pretty decent process. In fact, calcium oxide is one of the things that's used for this kind of an operation now. The problem with these solid ones is that when you go through these cycles, you end up getting them sintering and breaking and all sorts of things that are happening to them, and the performance degrades very, very quickly. So we've developed a new set of solvents which are based on molten salts. So it's taken any kind of a salt, not any kind of a particular types of salts, that are molten at the temperatures of interest. And not only are they molten, but they also have very high capacity and ability to absorb CO2 from the gases, emitted gases, at the high temperatures, about 600, 700 degrees Celsius. And we can then capture the CO2 in this way. The nice part about it is, because they're molten, is that we can just move them around like we would normally do with an amine solution, from an absorption column to a desorption column, where we can strip off the CO2 as a pure CO2 and then return the salt back to the absorption column. So that is one of the big advantages, particular potential advantages of this system. There are ways which you might be able to regenerate the CO2, either by temperature swing or pressure swing type operations, but they seem to be very efficient from what you've seen.